Alright, welcome to CAASPP Target O. So here are example questions for your packet. Let's get started. Okay, let's do first question here. So you will see up here that if there is a calculator, that means you can use your calculator. In this case, there's no calculator, so we won't be using a calculator for this section. Alright, so consider this right triangle. What is the value of sine B? So here we are dealing with a trig function, trigonometric function. So this is where you use your SOHCAHTOA. Okay, we are looking at angle B. Angle B is right here. So let's label the O and A and H. Opposite my B is 3, so that will be O. Adjacent of B is 4. Remember, opposite our 90-degree angle is our hypotenuse. Okay, we are looking for sine. Sine starts with an S, so we will be using this one. Okay, sine B is equal to opposite over hypotenuse. So all we do is plug in. So sine B is equal to O, which is 3. Our H is 5. Therefore, sine of B is 3/5. Okay, if you need to play that a little slower, then just go back a little bit. So that's pretty much it for this question. If you have any questions, let me know on the comments. Otherwise, I'm going to keep going. All right, number 2. Again, this doesn't have a calculator up here, so we are not going to be using a calculator here. Question says, consider this right triangle. Determine whether each question is correct. Select yes or no for each equation. So in this case, we are deciding whether this is correct, this ratio is correct, these. So we are going to start with sine A. Sine A, so we will be looking at this angle here. At sine A, here's my opposite, here's my adjacent. Remember, opposite my 90 degrees is my hypotenuse. So let's see, sine, so let's put our SOHCAHTOA. We are looking at sine of A, so what's the opposite of sine A? So, right, opposite of our hypotenuse, our opposite is 4, hypotenuse is 5, so is A true? Yes. Next we have cosine of A, so let's erase, whoops, sorry, not yet. So we are using the same reference point here. We're looking at A. So what's cosine of A? We are looking at C. Whoops. We are looking at C here, right? Cosine of A. So cosine A is equal to adjacent over hypotenuse. My A is 3. Hypotenuse is 5. So is this ratio true? No. Next, we're looking at sine of B. Now we're looking at B. So let's erase all of these. We're going to be looking at B right here. If it lets me. Right here. B is right here. So sine, again, sine, now we're still using so here. But our new reference point is B's sine, so it's opposite of our hypotenuse. So at B, my opposite is 3. Adjacent will be 4. And my hypotenuse will be 5. So O is 3. H is 5. So is this ratio true? Yes, it is true. Next, let's look at cosine of b. Cosine of b is, again, it is adjacent over hypotenuse. So adjacent of b is 4, h is 5. Is this ratio true? No. Okay, that's it. This is all you have to do here. You're just checking based on the reference point and based on your SOHCAHTOA. Okay, I hope that makes sense. Otherwise, leave a comment to ask a question. Next, here, this is exactly like number 1, except it's not multiple choice. Okay, sine of b, again, sine of b is here. Opposite, adjacent, hypotenuse. Sine of b will be opposite over hypotenuse, which is 3 over 5. Okay, next question here. So this is now similarity. Triangle ABC is similar to triangle WYZ. Remember, similar symbol means we are looking at ratios or fractions, scale factor kind of stuff. So considering that these two are similar triangles, this means that the ratio or the scale is the exact same thing. So if this was divided into 2, so if this is divided by 2, whoops. So if this side is 3 divided by 2, this would be 5 divided by 2. Here would be 4 divided by 2. All right, that's just an example. It's not real. So that means if this is 3 over 4, this is similar to those two same numbers. So if my tangent here is 3 over 4, remember tangent is opposite over adjacent. We're gonna look for angles whose OA is 3 over 4. So we want 3 to be an opposite. We want 4 to be an A. We don't need the hypotenuse. So if it was A, our opposite would be 4. Is that what we want? No. So let's look at angle B here. Angle B, 3 is indeed my opposite. 4 is my adjacent. So we already know that angle B is true. Since angle B is in the same spot as angle Y, then that must mean angle Y is true. So this occurs when they are similar triangles. They must be similar. Okay. So number tangent is just TOA, just which one is the same. Which one it has tangent 3 over 4 when you're looking, which one has a ratio 3 over 4 when looking for the tangent of an angle. So it'd be angle B and angle Y. Okay, these two, here it says a calculator can be used. So in your CAASPP, they would give you a calculator. So let's sine 47 equal this here. Enter an angle measure beta where cosine of B equals the same number. So in here, remember that to find an angle, we have to use, so to find angle, we have to use inverse. So this is the same thing as cosine inverse. Let's see, I need more space. So the same thing as cosine inverse 0.7314 equals beta. Okay, and if you put this in your calculator, you should get beta equals 43 degrees. Okay, and this also goes for example 2, but I'll show you another way for example 2. For example 2, sine and cosine really just add up to 90 degrees. So sine and cosine add up to 90. Okay, if this is sine 30, to get beta, we just do 90 minus 30, which is 60 degrees. That's really it here. Yeah. All right, next problem here. Triangle ABC, similar triangle WYZ. Okay, this one is a lot of work, but once you get things done, everything will be easier. So here, WYZ. So to make this easier, it's way better to just redraw it. So I have triangle ACB here. ACB, so I'm gonna redraw this so that they're in the same orientation. So A is the same spot as W. B is the same spot as Y. And the other one's Z. And WZ is 5. ZY is 12. Okay, and we do know, oops, let's stay here then. And we do know that 26 is here for AB, but we don't know what WY is. So to figure out WY, remember, we don't necessarily have to use the trig functions. When we know two sides, we can use the Pythagorean theorem. So to get this side here, I'm going to use the Pythagorean theorem of a squared plus b squared equals c squared. So in this case, 5 squared plus 12 squared equals c squared. Remember, c squared is our hypotenuse. So this is 25 plus 144, which is the same thing as c squared. So 169 equals c squared and then we square root to get rid of the square. Square root of 169 is 13. Okay, the reason why I'm not using negative 13 here, because obviously a length can never be negative. So our C here is 13. Okay, since AB, this side, and WY are similar, so if we did a ratio here, we are trying to let's find all these other sides here. So let's do AC over AB is equal to, so AC over AB, same thing as WZ over WY. Okay, so I'm gonna erase all this work here. So now let's do this. So AC, we don't know, right? We don't know AC. AC, AB is 26 equals WZ is 5, WY is 13. So 13, we know 13 can go to 26 2 times. So whatever I do on the bottom, I must do on top. So 5 times 2 is 10. That means this missing side here is 10. So we notice that it's just being multiplied by 2. That means 12 times 2 would be 24 here. 24. So 2 is what we would call our scale factor. So now we can compare, Now we can compare. Thankfully, we can use a calculator here. So determine whether each statement is true. So now let's look at sine A. Sine A, I'm going to use green. I'm going to go ahead and erase the others. Other stuff here. So let's look at sine A. Sine A, we have our opposite here, adjacent, hypotenuse. Sine A is 24. So 24 over, so hypotenuse is 26, is less than what sine of y? It is 5 over 13. Okay, just by looking at these numbers, 24 is closest to the whole number of making it into 26. 5 is further away from 13, or you can use a calculator. You can put 24 divided by 26 and is less than 5 divided by 13. What you will find is 24 over 26 is much greater than 5 over 13. Therefore, this is false. Okay, in order for this to be true, it has to go this way. Okay, now let's find cosine of b. Cosine of b. So now we're changing our reference here. So I'm going to erase all the greens. Cosine of b, right here. This is adjacent and the hypotenuse. Cosine of b is 24 over 26 is equal to sine w. This is w. Sine is 12 over 13. Right? 12 over 13. This, if I multiply this by 2, if I multiply it by 2, they become equal. So this is true. Okay? So if I simplify 24 over 26 is the same thing as 12 over 13. So that is true. Next, we have tangent W. Tangent W. So where's W here? Tangent of W, so that's 12 over 5 is greater than tangent of A. So tangent of A is 24 over 10. If you use a calculator for this, you will figure out that these two are actually equal. Because if I multiply this by 2, it's the same thing as 24 over 10. So it's false. Okay, this one's kind of a little bit complicated. But first things first is if you can figure out all these side lengths, then you are good. Okay, if you have any questions for that, if you want to see this in person, let me know. Next problem here. Consider this right triangle. Determine whether each expression can be used to find the length of AC. AC, right here. Okay, AC. Again, all of these are just referencing trig functions. So let's look at B, side B. In side B, I want to find this is opposite over hypotenuse, right? So again, SOHCAHTOA. Okay, it says sine, so we're using S. So sine of B is equal to O over 13. Right, H. So if I multiply to find O, I have to multiply 13 on both sides. Let's see if I can, yep. Times 13. Okay. So at the end, you'll get 13 times sine B, or 13 sine B equals O. Okay, so yes, or AC. Okay, so yes, we can use 13 times sine B to find AC. Next, we'll do, so I'll do one more, and after that, I know you guys can figure it out on your own. Next, we'll look at cosine of A. Cosine of A. So this will be opposite, this will be adjacent. So cosine of A will be adjacent over hypotenuse. So cosine A is equal to A, or AC, over hypotenuse, which is 13. So if I multiply 13 to both sides, I do get 13 cosine A is equal to AC. So yes, I can use this to find AC. Okay, so I'm just going to do those two examples, and I know you guys can do the rest. All right, here we go. Here's the next one. Consider this right triangle, enter the length of AC to find to the nearest tenth. So I guess this is the favorite, AC. Okay. So this is our angle, opposite, hypotenuse, and adjacent. Okay, so how do you figure out what to use here? Do I use SO, CA, or TOA? Okay, let's see. We are trying to look for AC, so we need the opposite. So it can be CA, right, as an A. We need the opposite, and does it give us an A? Not really. So it can't be this, and it does give us an H, so we must use sine. So sine of 64 degrees is equal to opposite over H. So instead of opposite, I'm going to use AC because it looks like 0. H is 15. Okay, so let's get rid of our denominator. Times 15 times 15. So AC is equal to 15 times sine 64. Okay, I don't know. I don't have a calculator right now, but it will be an approximate number here. And make sure it's the nearest tenth. That means you only get 1 decimal place. So if I did 15 times sine 64, let me use my phone here. 16 times, or okay, 15 times sine 64, you should get around 13.5. 13.5. If I made a mistake, please let me know in the comments. Okay, next one here. Find the angle measure of angle A to the nearest degree. This means to the nearest whole number, basically. Okay, remember, to find an angle measure, we have to use the inverse. So we will be using, we'll still look at SOHCAHTOA TOA. Let's look at this first, okay? So we won't use the Pythagorean theorem here either, because we're not looking for AC. We're looking for side angle A. So let's label the stuff here. We have opposite, adjacent, and hypotenuse. So do we have an A? No, we don't. So we can't be using either one of these. So we must use SO. So we would use sine inverse of opposite, which is 12, over hypotenuse, which is 15, is equal to angle A. Okay, so if you use your calculator here, you should get, if you use it correctly, 12 divided by 15, you should get 53 degrees. So measure of angle A equals 53 degrees. Okay, find angle measure, use inverse. All right, here you go. Here's the next one. Bob uses a 20-foot ladder to paint a section of his of his house that is 16 feet high. Select all equations that can be used to solve for theta. So we are looking for theta. What you guys don't know is you actually have to solve for x here. So in order to solve for x, I'm just going to use a Pythagorean theorem. So that's a squared plus b squared equals c squared. So a squared, I'm going to say 16 squared plus b squared equals 20 squared. Again, you can use a calculator. So 16 times 16 is 256. 256 plus b squared equals 400. So subtract 256. B squared equals 144. Square root. B equals 12. Again, I don't use plus or minus 12 here because a length cannot be negative. So our x here will be 12. Okay, so now let's figure out if we can find theta using this. So sine of theta, again, this is opposite, adjacent, and hypotenuse. So SOHCAHTOA, sine of 12 over 20, let's see, sine, our O is, let's see, our O is 16 over 20. Is that our sine? So this is incorrect. It's not it. Let's find our cosine of theta. Cosine of theta is 12 over 20. Is this true? Yes. How about tangent? So tan theta is equal to 16 over 12. This is wrong. Sine theta, this is right. Cosine theta is wrong. And I'm just going to assume this is 16 over 12. And I'm going to make it right. That's it. So just need to figure out what the other side is using the Pythagorean theorem. Okay. Next, last one, right? Donna wants to calculate the height of a tree. She makes the following measurements. The length of the tree's shadow is 29 meters. The angle of elevation from the ground to the top of the tree is 30 degrees. So whenever it's telling you the angle of elevation will be from the ground up. Okay, it'll never be up here. It's always from the ground up. From the ground up. So it's already labeled for you. What are we looking for here? We're looking for the height of the tree in meters. Thankfully, these are already in meters. So we don't need to convert anything. We have to round our answer to the nearest whole meter. So we have to find the height. So I'm going to call it, well, let's label it here. This is my opposite, adjacent, hypotenuse. So we are looking for the height of the tree, which is my opposite. So if I have my opposite, if I'm looking for my opposite and I have my A, which one would I use? Okay, I have an A and an O. So I have an O and an A. There's no H, so these two immediately cancels and we will be using tangent. So here we would do tangent of 30 degrees is equal to opposite, which is my height, over adjacent, which is 29. So I would just multiply 29 to both sides here. So 29 times tangent 30 is times 29, sorry, 29. So the height is equal to 17 meters. Okay, it's approximately 17 meters. All right, that's it. If you have any questions for any one of these, just give me the number, what number it is, and write a comment or anything, or ask me in person. All right, I hope this helps. Bye.